All right, so today we're working on a 2006 Lexus GX470, and I am doing a power steering rack swap with a GX460 rack and a GX470 chassis. It's a pretty common swap for people to do for a few reasons. The GX460 rack is much less expensive. It's about $800 or $900 compared to about $1,200 for the GX470. And it's got some design improvements. It's stronger, bigger parts, and so forth. So there's a lot of information about how to do the swap on the internet. Some of it is wrong, some of it's kind of wrong, some of it's inaccurate. Conflicting statements all over. So I'm gonna try to clear that up for you and give you the rundown of what it takes to do the swap. So we've got our new rack and our old rack here. And, the main differences are, like I said, the components are a little beefier on the new rack. This body is about, I think it's 2 or 3 millimeters larger. And so are the tie rod ends. Both the inner and outer tie rod ends are beefier. The other main differences are the bolting locations for the mounts. The original GX470 racks used a M12, which I have here in my hand, and the new rack uses an M14. So it's pretty common for people to buy the M14 bolts and come over here to the subframe and drill those holes out. Right here, then there's another one on the other side, and drill that hole out to the M14 diameter. But I don't believe you need to do that, and I'm gonna explain why in a bit. And I really just don't want to do it because it's going to be a pain. It's a bit of a risky operation. You need to buy some drill bits that kind of step up in size gradually, or maybe a reamer bit to do that work. And enlarging a hole like this with a gap between, whatever that is, 2 or 3 inches between the bottom one and the top one, you kind of risk your drill getting caught up and breaking your wrist or something. So really don't want to do it and don't need to do it, and I'll explain why. Okay, so let's look at the original mounting locations with the original bolts. All right, so I've got an M12 and a 12 millimeter hole. It's a decent fit, but it's still pretty loose. And if we compare that with the original bolt in the new rack hole, we've got quite a bit more play here, right? It's made for a bigger bolt. Well, when you assemble all this together and torque this bolt down to spec, the clamp load on this is about 8,000 pounds, a little bit more than that. So you've got 8,000 pounds for one bolt. With 2 bolts, you're at 16,000 pounds. And when you clamp all these together, this entire assembly, with the subframe, the rack, the bolting, everything becomes one unit. So you've got, it's gonna be a little tricky to show this. Let's see if we can do it. See, there's a bit of a gap between the upper bushing and the lower bushing sleeve there. When you clamp all that together, that gap will close and these bushings will become one unit in a sleeve like this one. This is an aftermarket polyurethane bushing, and it comes with one solid sleeve. So the clamp loading is really high, and it's designed so that when you clamp all this together, you're just relying on friction between the bottom mounting location and the subframe to prevent that lateral movement. So if we look at our old bushings, This was the top original bushing on the GX470 rack. It's got 200,000 miles on it, had some heavy off-road use and sometimes abuse, and there's no evidence that that bolting has ever moved or has come in contact with the bolt in shear, right? So in bolting design, we would call that, if these come in contact with each other and the bolt is resisting the load, it would be called a bearing shear load. And there's no evidence that that has ever occurred in the 200,000 miles and the abuse I've put this truck through. Which tells me that that friction fit I was talking about to eliminate those lateral movements is working, and that's the way it was designed. So another piece of evidence for that is this polyurethane bushing is made by a reputable company, and it's designed specifically for the GX470. And if we look at the fit on that one, right, it's plenty sloppy. Similar to this, this one's a little bit more. It's about a millimeter difference. I think this one's about 13 millimeters. This one's about 14. But either way, you can tell, this is an engineered product from a reputable company. It's clear that that fit doesn't matter all that much. Some further evidence of this is the machine work that's on these. Well, sorry, that may have messed up the video, but the machine work that's on these components here. So they've got a really nice surface finish. That's a extra step, a machining process that costs money, and these automotive manufacturers are not in the business of doing extra machine work for fun. So the idea with this surface finish is to provide grip for that friction fit I was talking about earlier, the friction that prevents those lateral movements. Okay, so in continuing talking about the bolting, this bolt has an odd mark on it. It's got 2 dashes, and I can't find what that means in any of the Toyota manuals. They're usually marked differently. But we can do a little investigation to figure out what kind of bolt this is, what material it's made from, or what strength grade it is. So if we look at the Toyota specs for torque on that mounting location, it's 74 foot-pounds. Okay, so we can take that torque spec from Toyota and go to the Fastenal metric charts, and it matches up most closely to the grade 8.8 or class 8.8, which would be about the equivalent to a grade 5 in the good old USA. So the torque spec for that is about 65 foot-pounds, and they usually do these charts at about 70% of yield. It's possible Toyota's taking it a little bit further with this 74 foot-pounds, or they're using a different K factor based on the coating or the material of this bolt. So when we clamp this bolt down to the spec, the clamping load is 8,240 pounds for each bolt. If you do the friction calculations, and I reduced the friction calculation by 15%, that's what this 0.85 is for, you're still in the ballpark of 8,000 pounds of force that it would take to move that rack laterally per bolt. So it'd be about 16,000 pounds for the 2 bolts combined. So it's unlikely to happen, and as I showed you before on the old rack that's got 200,000 miles on it with some off-road abuse, there's no evidence that's ever happened. All right, so while we're on the subject of bolting, this is the nut that goes on the bottom and clamps to the subframe. You can see this nut was originally staked, and I didn't know that until I took it apart. But so I loosened the nut from the nut side rather than the bolt head side and damaged these stakes. So it's a good idea to get some new bolts, or I'm sorry, new nuts with new stakes. And when you make this assembly up, You want to allow these stakes to eat into the subframe by leaving this nut stationary and torquing it down with the top of the bolt. And that will prevent this from coming loose in the future. You can also use Loctite, but while we're on the subject of bolting still, using Loctite does act like a lubricant, so it will take your K factor down a bit. So, you know, a dry or kind of a coated bolt spec might be this K factor 0.2. When you lubricate it with a anti-seize or a proper lubricant like that, maybe a jet lube, it goes down to 0.15, and therefore your torque spec goes down to about 48, 49 foot-pounds rather than the 65. But Toyota calls for 74. I'm going to use some Loctite. Like I said, this isn't rocket science, but I'll probably end up using about the 65 spec for a bolt that's lubricated with jet lube. But anyway, there's some wiggle room in all this. It's not exactly rocket science. Okay, so the other main differences between these racks are on the hydraulic fittings. So if we look at the original GX460 rack, ignore this one, it's been modified already. We'll take a look at this one. So in there we've got a 45-degree flare fitting, and that's on the high pressure side. This is the return side. That's, again, ignore that, it's been modified. So if we take a look at the new rack, our fittings are different. This one is designed to accept an O-ring seal on the surface that's right about there. It's about a 10 millimeter diameter. Same thing on this one. It accepts an O-ring style fitting. So I'll show you what those look like and the differences between them. So this is the original 470 low pressure return, and it has a 45-degree flare style fitting. I believe it's a double flare. Okay, so this is the new fitting for the GX460 rack. So it has a unique type of flare that you cannot recreate with hand tools. It's a special machine to make this, and then there's an O-ring there, and that O-ring's about 11 millimeters in diameter. The hole on the rack is about 10 millimeters in diameter, and that sits down in that hole and seals off, and you torque it down with this. Okay, so the part number for that is here, and you certainly want to buy one of those return lines when you do this job. So that still leaves you with the high pressure side. So what do you do with the high pressure side? So the high pressure side has that same 45-degree flare fitting on it, but our new rack is not really designed to accept that. A lot of people have reported they just bolt this together and it's a direct fit and it doesn't leak. Okay, well, that's probably true for a lot of folks, but that may only work one time, and I'll explain why. And let's go back over here. So in a proper seal, you would have kind of a bell housing like this mating against this surface, and it would seal on that entire surface. Well, if you try to bolt this into the new rack, it's going to want to seal on this surface here, just the outer edge, and it may deform your flare. So the only way that would work is if your surface here has not been damaged, it's not scratched or dented. It may work 1 or 2 times before it gets too deformed to continue working. So you have a couple options on what you can do with that. One option is to buy one of these fittings, and the O-ring that's on here was originally sitting right here. So you buy one of these fittings. It's a 16 millimeter by 1.5. That's the thread pitch. And then it converts to a JIC 37-degree flare fitting. So you could take this with the O-ring, thread that into your rack, and then cut your old flare off the high pressure side, slip all this on, do a new flare, and then assemble it all together, right? So you would then assemble it. You would then assemble it, right, and with that new flare and put it together. But I don't really want to cut that old line and do the flare work. So what's the other option? So this is a part that I took off of the old rack. It's a little brass bushing that was on the return side of the old rack, and I put an O-ring on it. So what that would look like, we go back to the old rack here. So on the high pressure side, you've got one of those 45-degree flare fittings. There's a ball check valve situation going on down there. That's not the one you want to pull. On the return side, there's a similar arrangement, but it doesn't have that check valve. So you just take a hook tool, get underneath that brass fitting, and rip it out. And then what you have is this. So, and then you add an O-ring to it, and that will seat in the rack. This flare side will fit here, and then that O-ring will seat in the new rack, and you have a joint that should seal efficiently. Okay, so just to show you what the looked like originally with the O-ring on it, this is how you would buy it at the store. You would find these at a hydraulic fitting store. And again, it's a 16 millimeter by 1.5 thread pitch to a JIC, I believe it's a 3/8 JIC fitting. JIC and AN are similar. You could also use an AN. The ANs are built to higher standards. They're a little bit more expensive. But for a car, the JIC fittings will work just fine. Okay, so I believe that sums up kind of the differences and the pitfalls for the, the differences between the 470 and the 460 rack, and the challenges you may have when doing the swap. Hopefully this clears up some of the information that's out there. And I'm not going to do a whole video about how to take these racks and in and out of the vehicle. There's plenty of other information out there about that. But I can give you a couple tips real quick about how to do it. So, so this hole right here, this big hole, allows you to slide the rack out this way towards the passenger side. And so you want to push it through this hole as much as you can, and then angle it out through this passage going out the front. It's pretty tricky to do. To do it, I removed the differential mounts, and it was still pretty difficult. My shock was also in the way, so I took that out, and that helps you get a little bit further this way with the rack to angle it out. And then to put the new rack in, it is a little bigger, so I think what I'm going to do is loosen the engine mounting brackets and the transmission mounts, and there's some other stuff up here in the hood you got to do, I think it's the radiator shroud and a few other little things you got to loosen up, and you can get a floor jack and lift the engine up a little bit, and that should give you some more room to get that new rack in. But that's essentially how it's done. Yeah, like I said, there's plenty of other videos out there about it. The purpose of this video was essentially to explain the differences between these racks and the challenges you may have. I'm gonna go ahead and bolt it back together with the original 12 mil bolts, including the loose fit here, and I believe everything's gonna be okay. But if it's not, I'll update you guys later. All right, so this will be the end of the steering rack video. It's been about a month and about 1,000 miles of driving with the new GX460 steering rack. And so far so good with the conversion gasket, the brass bushing, so no leaks there. And the using the 12 millimeter original 470 bolts, steering rack's been solid, hasn't moved at all, and the alignment's holding. So I'm pretty confident in that. We'll find out on the next off-road trip if that remains to be true, but I've bashed it pretty good into some curbs and potholes and so forth, and it's holding up good. So yeah, like I said, that'll conclude the video on the 460 steering rack swap into a 470, and yeah, good luck with the conversion.